We are live. Welcome everybody to another webinar of Data-Minded. So I'm 𝗁𝗁 I'm the CEO of Data-Minded, and I have two fabulous guests with me. Well, guests, two other people from Data-Minded. So Christophe, if you want to introduce yourself.
Thank you, Chris. I'm Christophe. I am a team lead within Data-Minded, and I work with companies and organizations building data platforms at scale. They're usually highly governed, and they have quite security and governance aspects that need to be considered.
All right, and Jelle?
Hey, so my name is Jelle. I'm also a team lead at Data-Minded, and I'm currently active as the lead platform engineer for the client I'm working for. So my main job is to enable other teams to be productive.
Cool, welcome. I'll be the moderator here, but I won't add anything useful. These guys have prepared some beautiful content. Before we dive into the content, there are a few questions we would like to ask the audience. So in the chat, you should see a link. Somebody is not hearing audio. Is everybody else hearing audio, or do we have another case of bad audio? Let me know. I hear you fine. Okay, Luc, it's probably with you. If you guys can follow the link that I put in the chat, I'll also start sharing my screen. As usual, we have a Mentimeter to start the session. Sec. Oof. Yeah. It's coming. All right. Please can you all go to menti.com and enter the code 34571077, or use the QR code, or follow the link on the screen. All three things bring you to the same location. I'll wait a bit so you can all go to menti.com. Try to make it as interactive as possible, because we're now just talking to a webcam, right? So I'm curious what you think. All right. Maybe as a first question, so you decided to join this webinar. What do you want to get out of it? We have an hour together, so I'm curious to know what you would hope to get out of the webinar. As a reminder, we're going to talk about centralization versus decentralization of data organizations. What do you do centrally? What do you do decentrally? Is the one extreme good? Is the other extreme good? How do you combine the two? What do you need to take care of? You want to know the difference? Okay, fair. Inspiration for my upcoming reorg. That sounds gloomy. I hope your team is okay. Get ideas and best practices. Yeah. Best practice, practical examples. Yeah, I think, Jelle, if I'm not mistaken, we're going to end up with a practical example, right? Yeah. Yes. So you have to wait all the way to the end, like first slides, and then you'll see a practical example. What are the pros and cons of the two options? Know more on when to use what. I like that as well. If hybrids are possible, insights from your experience. Impact on data governance is a big one as well. What are the right drivers to centralize or decentralize? Yeah. Others are doing how to decentralize as much as possible. Yeah, hybrid. How relevant is this for a startup? 3-4 analytics engineers, 40 people in total. I want to quote 𝗁𝗁, who now works at DPG, who used to work at Data-Minded, and he says, the best thing in the world for data teams is if it's only 8 people, and those 8 people can do everything. Then you don't need any of this. So in a good way, I think if you're a startup and you have 3 or 4 analytics engineers, there's not much to decentralize, right? So I don't know if
we're also going to cover that. So
yeah.
Don't spoil all the beans yet.
How to write ownership. Yeah, all right. This gives us a fairly good idea. Next, we want to assess where you are today. It's a bit 4 black and white questions, and you either strongly disagree or strongly agree. So for your data organization, everything is done in a single centralized data organization. So how much are you centralized? Second, have you embraced and adopted the data mesh philosophy? It's becoming an ugly word, but what are your steps there? Do you have a self-service data platform that can be used by decentralized data product teams? And do you already have the right governance in place to make teams work autonomous? The last one is a bit of a pain question, because most of you, what we experience from reality is most of you don't have the right governance in place yet. That's actually one of the topics that we're working on. Okay, so what do we see? There's very bipolar answers in the first 3 questions, right? So Some of you are centralized, some of you decentralized. Not a lot of you have done a lot with data mesh yet, or not a lot of you are really at the cutting edge here. Okay, but you do have a self-service platform that can be used by decentralized teams. That's good. But yeah, so the delta between these two are interesting, right? The platform is there, the governance is not. Yeah. Okay. All right. Well, I think the pattern is clear, right? It might change a bit. And then finally, open-ended. What are some current challenges you're facing? What are you struggling with today? I guess governance is one of them, coming from the previous slide. I'll wait a bit for some answers. A maze of data flows. It could be the title of a novel. Too many source systems from acquisitions, yeah. Convincing a certain path and defending it with business. What is the best versus what is feasible? Don't find the right people. Adoption, integration, ease of use. Yeah, the adoption integration part is, I won't spoil it, but Jelle is going to come back to that. Balance between self-service and control. Lots of data, lack of overview. Yeah, we see similar things at the clients we work at, right? So you're not alone. Governance, understanding the importance of managing data. Replication of content, and therefore inefficient use of resources. Yeah, can imagine modeling of data in a warehouse for the medium versus long term. Yeah. I like how you use data. That's exactly how we intended it. Very disparate data and topics, inconsistency, and laissez-faire at different acquisitions. Quite a few of you are dealing with acquisitions. No integration at the org level. Automate and scale data platform with a limited team. How to create a winning team. What do you centralize and what do you decentralize? Okay, I think here are some patterns as well. We're going to switch to presentation. I'm going to leave this Q&A slide open, so feel free to ask anything you want here. You can also ask in the chat of the webinar geek. We'll come back to this at the end of the presentation. With that, I want to give the floor to Christoph.
Thank you, Chris.
All yours.
All right, so for today's presentation, we'd like to talk about how to build data platforms, how to organize teams around that, and to consider how to consider aspects related to centralization and decentralization. But before we actually dive into those topics, I think it's a good idea to step back and to think about what the strategic goals are of your company, and that you just don't build a platform just for the sake of it, but it needs to solve problems in your organization, and it needs to be completely aligned before you actually do that. Then Jelle will talk a little bit about how you can organize your data teams and your platform and how they will work together and relate to each other. And then some practical tips on how to get started. And then I will talk a little bit about how you, when you are building a platform that needs to run at scale, how to consider centralization and decentralization topics. So that's what I would like to call the values of freedom and control are not conflicting with each other. All right, so let's dive into the first topic. So regardless of what your company's strategic goal is, where you're working, would like to work on, and that can be many different things. Like, for example, you want to improve your operations, create new services, become more data-driven to be able to make better decisions. You want to get closer to each other. The chances are very high that that having access to data and doing analytics and building data products on top of that will have or will play a big part in getting there. But what we have learned is that it's not always that straightforward to make that translation to those strategic goals, to building a platform, building teams, and so on to be able to get there. It's about how can you get access to the data, how can you make it open for the whole organization to use. We have seen in many cases that IT and the way that IT is organized in bigger organizations is not really suiting for big data and big data processing. So what usually happens is that the business starts with a credit card, they go to AWS or to Azure, and people will start building stuff, and they immediately get big value and big benefits out of that. And then immediately also the question becomes, okay, now it's there, please maintain it and support it for me. And at the same time, all of the data that is there, also make sure that it can be shared in the rest of the organization. So immediately IT comes back into the picture, and you want to be careful that if you're in that kind of a situation, that you keep your focus on solving business goals and that you do not end up in kind of a constant battle between IT and business. So focus should be on solving your business challenges and not on solving IT problems. And this was also related to one of the questions in chat. If you are building a data platform, you also have to consider that every company is different. So there can be a lot of Medium blog posts and other resources that you can find on the internet. And it's not that you can just say, this is a blueprint for a data platform and a way of work, and I'm just going to translate it to my company. So you cannot actually do that, because every company is different. When you are a startup and when you are with, just like in the example, with just 20 to 40 people, do you really need a data platform? Because, you want to move fast and so on, and you have usually very technically skilled, strong people. Basically, if you have your AWS or your Azure account, all of the data is there. You have your website there, your database is there, so it's easy to just extract them and get them to working. So you might consider even the question: do I need a data platform? Do I need this self-service kind of thing? Because you don't have the scale to actually do that.
Or maybe what you say is like, you might have a data platform, but it's super simple. You just spin up a Snowflake or you spin up a Databricks and you get going and be done with it, right?
Yes, that's true, but you don't need to build the self-service capabilities. It's kind of, here is your, I don't know, Hadoop cluster or your Kubernetes cluster, whatever.
Hadoop is old.
I know, but I don't want to install sometimes. Anyway, but on the other end of the spectrum, you have like more enterprise organizations, they're bigger. And they're usually a little bit slower. Your tech skills are not always that good, because you have very good engineers, but you also have engineers that do not have all of the knowledge about AWS and infrastructure and so on, but they still want to be able to work with data, and you need to be able to bridge that gap. Also, the bigger you become, the more governance and legal and security and all kinds of non-functional requirements will start popping up, and then make things more complex. And when you're in that situation and you really want to work on tens or 100 use cases for data at the same time, I think it becomes relevant that you think about building a data platform and working with that. But on the other hand, you can also become really, really big when you're a financial institute, a bank, or a government, and so on. It might even be that you end up with multiple data platforms which will serve multiple purposes and so on. So the point I'm trying to make is, you cannot just copy-paste a blueprint for an architecture and immediately copy it to your company. You have to tie it to your strategic goals, and you also have to make sure that it fits to the needs of your company as well. Also, what we find very important is when we start a consultancy engagement in many companies, we see that IT is usually organized in a way like this, where you have a use case team, and they need to do something. They need to build a data product, a website, or whatever, and then they need to interact with like a data engineering team, an ingestion team, a data science team, the CI/CD team, and so on. And they ask them to do things for them. Please give me an AWS account, or please extract this data for me, and please set up this CI/CD pipeline. So it's always the work trickles down to the organization, and that team also relies on other teams and so on. And in the end, if you have something up and running, then your operational team needs to take over the responsibility to keep things alive. So one of the big drawbacks of these things is that you create a lot of dependencies between all of those teams that have different backlogs, different priorities, and this has a huge impact in how fast you will be able to build stuff and deliver them into production. So instead of being in the situation where you delegate responsibilities and tasks to other teams, we would basically propose to go for a different kind of approach, where you have the multiple use case teams and the organization ties himself to offering the capabilities to those teams to be able to work effectively. And you don't need to do everything, but for example, for a data team, it can be a means to give them all the tools they need to be able to do compute, get access to data, and so forth. And you basically shift the narrative. Those teams will become fully responsible to be able to build everything end-to-end, and it should be able to do it in a self-service way. And the platform team should support them to allow them to do that.
And not build the use cases themselves, right?
Yes.
That's super important.
Yes, that's correct. But and this is kind of a principle that you can relate if you want to build a website or a web service or whatever. So it's not only for data. This kind of platform thinking is often very useful also for other situations as well. And it kind of shifts the narrative of the perception of IT often being the bottleneck because there is a lack of resources. You shift the narrative of being IT becomes an enabler. And they enable the business and the use case teams to be able to do their work, and we need to be able to offer them the capabilities to actually do that. What is very important, though, is that the platform teams and the use case teams need to work together in a way that they're building the right capabilities. So it's a very bad idea just to build something and giving it into the hands and hoping that it will be the right thing. You need to evolve your platform together with your use cases. So just to make sure that you're building the right capabilities. One of the things I would like to warn for the moment you're starting building data platforms with architectures in general is what I would like to call the big design up front and analysis paralysis effect, where many organizations spend months, if not often years, discussing what their data platform should look like. And in more cases than not, they end up with architecture diagrams that look like something on the left. And this is very generic. These are usually very generic architecture diagrams that tell you, hey, we need to acquire data, we need to manage data and have a visualization layer on top of it. But it doesn't tell you how people will interact with it. How can you get access to data? How do you request access to data? How do you do your processing? How do you build? How do you deploy? So most of those architectures don't talk about how platforms are actually working and running and interacting with each other and how people will make use of it. So be careful of these kind of wish lists, because I don't call them really architectures. And don't spend too much on it. Of course, you should have a high-level idea on where you want to end up with, but what I feel is when you're building data platforms, you have to accept the fact that you do not know all the answers up front. And the best way sometimes to get started is to work together with some use case teams to actually start building something that works. And you gradually take in all the capabilities and so on, and the functionality that you need together with those use case teams. I would really recommend to start small with some kind of very high value use cases, which bring a lot of attention to it. And the moment you make a success, show that success, advocate your platform, luring others. It's kind of a network effect you need to get going, just to make sure that you can keep the hype going. Yep. So it's kind of build a plane while flying it, and it's very hard for companies to get into that kind of mode, but that's the only way what I've seen things actually working.
Yeah, I can be stronger. I know companies who spend years on the months, years on the left, and then trying in the end what they build is basically almost throw away, and they have to start from scratch anyway. Right, time to market is a feature as well. If you spend 5 years designing something, by the time you're done, everything is outdated. Right? That's how fast the data world goes, right? Like, so, but it's indeed something that's easy to put on slides, but companies struggle with that idea, right? Yeah.
That's correct. With this, I'm going to give the floor to Jelle, and you will tell a little bit more about what you see on the screen.
Yes, thanks, Christoph. So as you said, like ideally, IT should be an enabler for business. That's easier said than done. So what I want to do in the next section is look a bit at the relation between how you set up your data teams and how a data platform comes into the picture. And I think it's important to take a step back and look at how most organizations were certainly organized in the past, but certainly the bigger enterprises are still organized like this today, and how that leads to problems and what we can change about that. So if you look at how our organizations are organized, then you see that you typically have those very technically partitioned teams. Like you have a separate team of database admins, or maybe in a separate ops team. Maybe you have a visualization team, and maybe they are specialized in a certain technology like Qlik, backend, frontend. It differs per company, but the idea is those are the teams. So they were grouped based on their core competence. Now, this can lead to some problems. For example, the first one is who is thinking about the outcome as a whole. Like if I'm a backend engineer in the backend team, I know at some point I'm done with my code and I give it to the next one in line, which is probably the operations team, and they are responsible for putting it in production and making sure it works. So because everyone is operating in those weird silos, it's possible that you forget about the end users. Also, usually you don't get the full context. Like you get a ticket from another team, hey, please create this dashboard, here's my working API, or here's my data that is ready. So you don't know the full context of what is happening, and usually like what the end customer needs is not known in all those layers. So because of that, you also feel less ownership and accountable for your end result. And then finally, those teams, they have to communicate with each other. Usually they have separate sprint plannings. So they make tickets for each other, and there's like a dependency. And let's say that you're done with something and you create a ticket, please deploy this. It takes at least a day for the other person or the other team to pick that up. So you also have like a lack of agility and business adaptability. So this can lead to problems. If you then look at the book that came out, or what we can do about that, it's the book 𝗀𝗻𝗺. It came out in 2018. And basically, what they did is they conducted research across hundreds of organizations, software organizations across the world. And they came to the conclusion that we must ensure that delivery teams are cross-functional, where all the skills, so all the previous team we saw, all those skills must be present in the same team. The reason that they came to this conclusion is that feedback from live operational systems does not improve the software more rapidly, so you go faster, but also you develop like a heightened responsiveness to end users, so the people that actually need your product or your data. And the book Team Topologies also goes in details into that topic. So there in that book they call it a streamlined team, but that's the same idea. You have this cross-functional team that you see as like the most important team in the organization, and they go end to end. So if we map that conclusion and those ideas to data teams, then we will end up with something like this. So instead of having separate teams that own those technical key layers, you move towards like a long-lived product-oriented team where people with all those different expertises, they work together towards a shared goal. The advantage here is that they probably have a stronger feeling of ownership, because now that team, for example, knows we collectively own the promotions flow within the organization. All the work related to promotions will come to our team. Probably they will have a say in that, how work related to promotions gets prioritized, what they pick up first. So they will also become like domain experts and can build a site on their own priorities. Also, they are now optimized for the flow of change, because they need to be able to get work done, of course, so they don't do that by tickets, but those people can just communicate and they can go faster. Typically, teams that work like this are also more motivated. If you ask an engineer, in what kind of team do you prefer working, and you say, do you like to work in a technical team, like in a front-end team or in a cross-functional team, typically they will say, I like working in a cross-functional team. And the reason for that is that is exactly because of this autonomy. They can become a master in their field, not only technically, but they can also become a domain expert, which is also something that you see more often lately. Like I worked 10 years with airplanes, so I know everything about the industry. So companies also hire for that domain knowledge. And then the final skill is purpose. Is purpose, having a purpose in the organization, knowing that all work related to something comes to you.
Because the opposite is also true, right? If you have engineers, and there are engineers out there who, maybe it's not even right or wrong, but they say, you know what, I really like to tweak databases. I become happy optimizing indexes and caches of databases. That's what drives me. I mean, kudos to them, but do you want them in your organization? Because what I want is people who worry about a client problem or a business problem and see databases as a tool. And if they can tweak the cache and the index of a database to solve the business problem, great. But like my purpose is to update caches and indexes in databases, it's usually not a click with me. I really try to find people who want to solve business problems, right?
Yeah, exactly. It's also a bit too easy to say, this team structure is always better than the technically partitioned one. Because one problem or potential problem with this kind of setup is that, let's say that you're a team of 8 people, you probably have maybe 2 data scientists, 2 analysts, 2 data engineers, maybe a product owner. So those people, that group together, they need to be able to deliver value. Yeah. So that means those people typically need to be more senior, and they need to be able to carry their own weight. Exactly. While if you work in technically partitioned teams, a front-end team with six developers, you can have more junior developers present because the other ones will take care of them. So there was also a question in the beginning, like we have a lack of skills, or it's hard to staff people. Well, it's way harder to staff those kind of teams than the technically partitioned teams. So that could be a reason to go for that kind of stuff. Now, if we believe that this works better and this, we go faster and we're optimized for the flow of change, then we have a problem. Namely, all those teams, they are autonomous, they will build products, but they will spend a lot of their day-to-day work on things that are not directly impacting business value. We call that undifferentiated heavy lifting. So, for example, they need to deploy that code somewhere. Everything that is deployed, it probably will output some logs. Every engineer wants access to the logs. They want access to metrics, and maybe they have Spark. They want a Spark history server to see the memory that was used. So ideally, all their time is focused towards delivering business value and the business logic. But in practice, you see that they have that they have to do a lot of this other work that isn't directly impacting business value. In fact, every company has to do those kind of things. It's a bit the core versus context thing. Ideally, they focus all their time on the core, but this context needs to happen. Yeah. So this is where the idea of platform teams come in. The goal of a platform team is to take that undifferentiated heavy lifting from those use case teams. So it's called undifferentiated heavy lifting because it's heavy lifting because it's still heavy work. It's not something that was easy, but it's undifferentiated. It doesn't make any difference. So platform team, they should try to take that off of those teams and make sure that they can deliver value with a high degree of autonomy. Of course, we need to help them do that. Like there's one part which is about building the platform, but the big second part is about, do they know how to use the platform? Like if you lock yourself in a basement and you just build a platform and then you hand it to the engineers, probably the chances are very big that you build something that they don't want to use or don't know how to use. So that needs to be a collaborative effort. Also, what you see on this slide is that there's other teams involved, like architecture, design, and security. You could also look at those teams as teams that enable those cross-functional teams. It's about the mindset. Instead of isolating yourself as an architect and saying, I decide everything and you come to my committee and I put an approval stamp on your design, they should also enable those use case teams and reach out to them directly. Same with security. Instead of being Mr. or Mr. No, you can also interact with those teams and try to deliver value for the company. So if we dive a bit deeper into a platform team, and we talk about the core principles, then one of the first one is about building paved roads. So a data platform is simply a close tools that you throw together. Like you can say, hey, I have AWS, I have Snowflake, maybe I have Azure, a bunch of other SaaS products, and here are the tools, go ahead and use them. If we do that, then every cross-functional use case team, they still have to set up those tools and use them. So it will probably still take a long time, and probably they will still have a lot of that undifferentiated heavy lifting. So what you should do instead is think about what is the high-level life cycle that every software product or data product goes through. And on a high level, it's the same for every data product. It doesn't matter which machine learning model it is or what software application it is. On a high level, every data product has to go through this life cycle. For example, in the beginning, typically you do some experimentation. You have some data somewhere available. You want to see, can I make some predictions? Can I make a valuable machine learning model out of it? Once you are happy with the result of that model, you can start industrializing it, implementing it, and making sure that it can be called daily, maybe in real time. Once that is done, you need to deploy it, and you have a certain version, you have artifacts, and then finally, once it's in production, you need to monitor it. So building paved roads is all about providing an integrated experience where you help people to walk through all of those steps. So building an integrated experience is about building the glue, building integration between all those tools, and making sure that it's logical for people to use, that it makes sense, that it's easy to use, and that they actually want to use it. So you want to make sure that the right architecture decisions, best practices, are done almost automatically, and that people come to the conclusion themselves that, hey, indeed, it's way easier to use this paved road than to build this myself. And by doing that, you find a balance between forced standardization, and everyone has to use this, and a very high degree of autonomy. So they still have autonomy, but because it's easy, it will standardize automatically a bit. Second principle about a data platform is don't force people to use your platform. And another key mistake we often see at clients is making the platform a tool about commands and control, and just telling people that they need to use the platform. If you make it hard for people to do their job, they will likely either bypass your controls or they will leave the company. Mm-hmm. And the engineers that do neither of those, you probably don't want to keep them anyways because they're just there and they roll on, but
they accept whatever.
They accept whatever, they have no opinion. So actually shadow IT can be a good thing because those people at least want to go forward.
Yeah, I always say whenever clients come to us, but this is a crappy process and it's done in Excel and it's horrible and those people are stupid. No. Those people are creating value despite of not having tools to do it properly, right? So you should be there. That's your primary target. You shouldn't blame them. You should celebrate them and help them, right?
Exactly. Yeah. So the moment you say that everybody has to use your platform, you immediately stop caring about making it easy to use. Yeah. And it goes from being about enablement back to being about control. So the platform should be the best way to do things, and you do that by focusing on ease of use.
Is the clicker not working? Sorry.
Yeah. Yes. So how you get this is by involving them, how the platform needs to evolve. One thing that we've tried and that works quite successfully is having a user-driven roadmaps. So you publish your roadmap of your platform team on a page, Confluence or whatever you use, and people can vote on items. They can add items themselves, and they can see what you're working on at the moment. And that way, you can capture like the biggest requests or the biggest pain points that people would like to see solved. Also, you see discussions can emerge to make that happen.
Just as a time check, like 35 minutes in.
Yes. So those were a bit the principles. So how do you get started? Let's make it a bit more concrete. Yeah. So this is another picture from the book Team Topologies. And basically, what it is about is that when you're just starting out on building a data platform, what you should do is work very closely together with the use case team that needs something from you. So instead of having like a separate platform team and a separate use case team, you should work together in one team in kind of a discovery mode, in a collaborative mode, where things are not super documented yet, but you have very fast iterations. At some point, you will have delivered something as a platform team that can be something small, like a documentation page or something that's working. And that will allow you at some point to go more, take your own path and go more out, take a distance from each other, not a forced marriage anymore. And exactly because you do that, when there's a second team that needs that exact same platform feature, they will be able to adopt that with way less collaboration, where you move towards like from a close collaboration mode to like delivering something as a service. So when you just start out, or anytime that you want to do something new or you introduce a new platform feature, you should always go back to that collaborative mode and really shadow the teams and really learn what they need. Otherwise, you have the risk of building something that will not be used, and that just wasted money, and the risk of adoption that is there. So an example. So what they talk about in book Team Topologies is building a thinnest viable platform. That means you only build what is needed, but no more. The platform should be the smallest thing that brings value. And in the beginning, that can be just a documentation page. For example, what you see here on the left is just documentation on how to create a SageMaker notebook on AWS. And maybe you write it on a Confluence page and you fill in the subnet IDs and the security group IDs, and you say, hey, copy paste this, and it will work, and you will have a notebook. But maybe what you see is that other teams also want notebooks, and maybe 5 teams need it at some point. So you say, okay, let's start building some things out, and let's really provide this self-service experience. That's the thing you see on the right, where people can pick their own machine size, they can choose their own Python version. They click create, and the notebook opens. So eventually you will want to build some things out, but don't build this big vision up front. Really try to learn from feedback in practice and what is actually needed, because it might be that it's a one-off thing and it's not worth really building that as a platform capability. Next up, documentation is a first-class deliverable of any platform team. If people don't know how to use your services, or don't even know if something exists, then there's no point in building things in the first place. So documentation is the ideal means to scale yourself and to make sure that people know what is out there. I've seen many documentation initiatives fail, where documentation is outdated, and then they try to fix it, and they start a new structure, and then that is also outdated within weeks or months. So what you should try to do is start really small, with a low number of high-quality pages, and because you write them in a high-quality way, people will not dare to add a documentation page that is of low quality. It's the broken window theory. You should try to audit them regularly. Also, when people join your platform, usually we have an onboarding exercise, so they get to know the most important, so they know the most important concepts. Also, consistent formats is really important, like how-to guides or an FAQ also really works. One thing we try to do is to never go more than 2 nestings deep, because that also doesn't really work and people don't find the way. And then finally, and final slide of this section is try to define your commitments, support channels, and workflow for each type of request. Typically, people do have questions about how to use a platform. And at some point at the client where I was at, I was getting at least 10 messages a day. And it was not transparent to anyone what I was doing because I was all day helping people fix things. So what we did is we moved to a central Slack or Teams channel in our case, where we collected all the questions, and every time we get a private message to fix something, we just redirect them to the channel, so it's transparent, so you have a bit of a community effect, and you help them there. Also, you should define your commitments. Typically, the first page of your documentation page should be like your vision, your mission statement, what the platform is, and how you want to support your users. All right. Then I will hand it back to Christophe.
Or is that Christophe, if you can time box your thing to max 10 minutes?
Yeah, it should be able.
Because then we have 10 minutes left for questions.
I think it should be fine.
Thank you.
So yeah, now that we have all of that context, we can really think about what to centralize and what to decentralize and how to work. It is important to understand how teams work, how platform teams work, to be able to make these kind of decisions. So I'm using the clicker. Yes, there it is. But before we get started there, I want to address the elephant in the room. Most of you most likely are aware of data mesh and data mesh principles, and you heard about it and read a blog post about it. Their concepts are very interesting, but it's not a religion. Don't be dogmatic about it. The principles are very practical and they're very appealing, and everybody's talking about it. But be practical. There is no such thing as a data mesh architecture that you can just copy paste and so on. It's about principles, ways of working and so on. So I find it really important that just take the stuff that works for you and skip all the rest. And also ask yourself the question, do you need it at my specific scale? Because if you really want data mesh and all of those things, ask yourself the question, do I really need it? Because if I'm with 5 people, yeah, does it even make sense?
Yeah.
Also, do not use data mesh as an excuse to decentralize everything. Like centralizing everything is a bad idea, decentralizing everything is also a very bad idea. So we need to get somewhere in the middle, and data mesh principles are very clear. That it doesn't mean that you want to go for data mesh that you can still not have any central components in place. What I also don't really like about data mesh is it introduces very ambiguous terminology. Like, for example, what is a data domain? If anyone knows and can give me a clear definition and how it translates to that, how that will be completely understandable for everybody in the organization, I will buy him a beer for free, because it's not so clear. And also, you have to be very careful in the domain and the domain thinking of it's not because I'll give an example. It's not because I do an ingestion of a data source that I'm the one that needs to approve data access for it. Or it's not because I'm using other data sources and I am creating a new data source that I'm also the one that needs to be able to approve access to it. So it's always a very ambiguous way of how to look at it. And data mesh makes an oversimplification, which is usually not a good representative of how companies sometimes actually work on that front. So
I'll go to the next slide.
Yeah. So I'm not going to spend too much time on this slide, but because of the ambiguous terminology that happens in data and data platforms, it's really important that you get your definition straight about what it means to be a data product, what it means to be a data environment, and so on. Make sure that you have simple concepts that are easy to explain and easy to understand, that are repeatable for all parts in your data platform. So I'll stop with that. Okay, so this one is actually quite important slide, at least for me. And the message I would like to bring across is, if those capabilities on the left side are all of the capabilities that you feel that should be part of your data platform, I think it's a very important concept that you as a team as an organization, need to decide more or less upfront where you want to put it. And what I mean for that, for example, you want to make ingestion self-service. That is a conscious choice that you want to make as an organization. If you want to do processing in some kind of a shared compute or compute cluster in a centralized way, that's also a conscious choice. And you as an organization need to more or less decide what is your long-term vision, where I want to end up. And I think it's a good idea to make these decisions upfront, because you might not be there at start, but knowing that this is your long-term vision where you want to end up with, this can help you in making the right choices and direction and explain the vision of what your data platform should look like. These kind of decisions are more important than having kind of an architecture in place, like, for example, the architecture diagram that I just showed. Okay. All right, so this is something new which we see popping up in organizations which are building data platforms. There is kind of a new needs popping up when you're really doing tens or hundreds of data use cases at scale in the same in an organization. It's kind of a need for a data portal. And this is something very practical. So it's not a data catalog, but it's kind of for the people actually working with the data, which is on the left side, the data engineers, scientists, and analysts. They have questions like, how do I get access to the data? How do I start a new use case? How do I request access to be able to use that data? When I have a new data source, how do I register it for sharing in the organization? So there are a lot of very practical questions that people working with data need to have and need to have resolved. Initially, it can start with just documentation, as Jelle said, but in the end, it can also end up with a process and a workflow and a way of working and kind of a landing page, and then it becomes very practical at some point in time. The bigger you are, the more use cases you have, the bigger the need there is on that side. But on the other hand, on the right side, you also have the business needs, where you need on a more central level be able to answer questions like, how is the data being used across the organizations? What are all the initiatives going on? How is my data being used? Who has access to my data? How do I, as a data owner, approve or revoke access to my data? And so on. So there are a lot of practical questions, but also governance questions. And this is where data portals can really help. Maybe just before you continue, Chris, we are going to start an open source initiative related to that. So if you're interested in having some inputs or what is in direction this is going, you can always contact us so we can have a discussion with you.
We can already demo based on mockups, right?
Yeah.
Anyway. I'm always overselling it.
Yes. So anyway, we're at the start. So okay, this is kind of a practical overview on how you can organize this in an AWS way of working. So let's make some assumptions here, and that you have some centralized capabilities, some self-service capabilities, and so on. Let's assume all of that data will be in a single AWS account, and you will have multiple data products or use cases running in parallel on top of that. And you provide separation for those data products across all of those layers on a security level, on an IAM level. So we can make sure that every processing, every data product and every team working on it will have a completely separate environment around that. The data platform team will take care of what Jelle called undifferentiated heavy lifting, about security, running infrastructure, logging, costing, and so on. They will also take care of the registration of new data projects, data assets, and so on. And they will all organize who has access to all of these kind of things. On the other side, you will have the self-service capabilities that will be taken care of. Yeah, anyway, Chris wants me to move fast.
Yeah, we have 50 seconds.
Okay, great. All right, so something practical, use Kubernetes as kind of a way to separate compute. I think it's something to really consider when you're thinking data platforms. a couple of words here: automate, 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 automate. Do not have any exceptions in place. Try to make sure that your core concepts are very strong and that you can automate that across the whole chain. And if you do that right, you can strike a good balance between, where you want to be decentralized and have in a self-service way. We had an example of how a paved road could look like. That's actually one of the questions, but I don't know whether we have time for that.
Yeah, let's first look at the other questions. So sorry about the timing issue, but I want to wrap up at 2 because I know everybody's busy. So I'm first going to go to questions. If there is time for an example, for those who want to stay a bit longer, we can look at the example. Right? So that's. Yeah, okay, no questions from the audience there. Feel free here in Mentimeter to go back to that slide, ask questions there. There were a few questions here, but let's start from the top. Isn't data ingested included in data engineering? Yeah, maybe I can answer that. It's part of data engineering, but not everything, right? And I think 𝗀𝗏 already said it. Who does the ingestion? You can debate. Like, do you do that centrally? Do you do that self-service? Do you do that decentralized? But you need to make a conscious decision on where that happens. Each has a pros and cons, I guess. This one was never mind. So Shri asks, how do you see federated data lakes in manufacturing plants for real-time streaming data scenarios? And then feeding, replicating to a central data lake. Is this a recommended architecture for more real-time aspects? Let me know.
Okay, that's a deep technical question, and an architect's response would be, it depends. If this is a data platform where you want to use analytics on top of a huge data set, it doesn't make sense to do that always in a streaming fashion. It does make sense to extract the data and put it in an analytical database and actually do something with it, where you can do queries and so on. So then you're doing that on a streaming platform might not always make the biggest sense. But if you need to have real-time, that you need to do real-time model inference based on the streaming data, you probably can use the data platform to build your model, but your inference will probably still happen in a streaming fashion. So it depends on the use case. There is no clear-cut answer, at least for me, on whether this is right or whether this is wrong.
Yeah, maybe technically you see that there's quite some advancements the last years regarding streaming and not having to use like a separate technology for that. Like in the past, it was always Kafka. But now what you see with those upcoming open table formats at Delta Lake, 𝗁𝗁, is that you can stream data directly into an 𝗁𝗁 table, and they support things like merge on read and not rewriting the whole packet file. And also you can read data in real time from 𝗁𝗁 tables as it comes in. Also things like Snowflake and Databricks, they support dynamic tables, which is like a stream processing engine. So also those things are made easier. So you can definitely have like a streaming architecture on a data lake, as long as you use those table formats on top of it.
Exactly. Maybe one last thing I want to add is also depends on which data you need to make a decision. If all the data is local in your machine and you do not need to join it with ERP data or customer data, whatever, to make whatever decision you're making, you can run the algorithm locally, right? I know this example of a manufacturer that takes pictures of their product when they go on a conveyor belt, and then when they detect the defect, they discard the product or something. Like, you do not need like sales information to make that decision. For others, it does make sense to move it to a central data lake or whatever, and to make more informed decisions, right? Okay, here Lander says, sometimes I hear that backend engineers feel underappreciated in their roles. It comes back with us as well. For instance, just a second, they might invest weeks in optimizing caches, achieving significant speed improvements, but their efforts go unnoticed because other team members don't fully grasp the technical complexities involved.
Yeah, I agree, and that's a bit also the problem with data engineering. You're not on the value side of things, you're not on the front-facing part, it's not the data science part, it's not the UI, so people think that's the most important part, while you really bring that value. Maybe one thing I want to add for the software engineers that are following is that in the coming years, you will have a very important role also with all the data hype that is going on and the investments in data, and the amount of money going for data right now has never been higher, is the data teams need access to high quality data. And how that is happening until now is that you probably give some admin credential or read-only user that can pull your relational database and you give access like that. But that is what leads to all the quality issues downstream. So what you should do as a backend engineer is deliberately share data that is modeled according to your domain knowledge, but optimized for reading. So that means not hyper normalized and people just connect to that, but you say, this is the interface I provide, a bit like a microservice, but not everything has to go over HTTP. And that is what you share, and that is what you spread around the organization. Because most of the issues we see come from that pattern where data engineer just ingests data, and that data was never meant to be shared. And the people are often not even aware that the data is being used for other downstream processes.
Well, we also try to do with clients, so we recognize the problem as well. If you're a platform engineer and you're not building the use cases themselves, so you're in an enabling team, but you measure your success by like the amount of people you've enabled, the amount of use cases that go live, the stability of your platform, the speed at which you can add a new feature. Like those are different kind of metrics that you use. But you have to stand it, so to speak. I know cases where one of our engineers was super frustrated because he did 90% of the work, and then a data scientist comes in, publishes the result, and they get all the credit from business. Yeah, that's life. I mean, that's If you don't like that, then you should become a data scientist, I guess. Quickly going forward in the questions, because I see we have 5 minutes left. So, question from Martha: Team Apple or Orange should be based on type of product, and thus the strategy of the organization. Is that a correct conclusion?
So how I look at that is that instead of fully decentralizing those teams, so those streamlined teams, what you can still have is like one data or IT department, but within that department you organize your teams according to the business, and that can be according to domain, it can be business capability, it can also be a grouping that logically belongs together, and then they own a part that belongs together. Typically, they have like a product owner that is in direct connection with the business, or is either the business themselves. So it depends, but it's just a logical grouping where they decide on all the priorities related to that kind of business line.
Yeah.
And maybe you're also talking about
sorry, I scrolled down here.
The team, and it's also related to the domain thingy. Sometimes I rather have that you think about a use case or a data product or a project that you're working on, and there are people working on that. So this might be enough context to basically have all the granularity that you need, right? So this is a use case, an initiative, those are the people working on it, and it's up to you to decide in your organization what makes the most sense on how to organize that. But starting from there, I think it's just more than enough concept that you need.
Indeed. Here another, when working with data domains, maybe so it's a good one for you. Do you apply the domain-driven design, for example, bounded context, setting a ubiquitous language, or another approach?
So I am a fan of the domain-driven design, but try to explain what a bounded context is to someone in an organization.
You would be surprised, but in the software world, almost everybody knows, and it's a common practice.
So not in the business world, right?
Not sure in software organizations.
Okay.
Anyway, so like I said, this is the reason why I asked if you can give me a very clear definition of what data domain means. Let's have a discussion about it, because when we talk to business people, everybody has their own interpretation about what it means. So it's very hard to have those concepts. That's the reason why I said it's sometimes easier to just talk about use cases, use case teams, and people working on those use case teams. And you might not even need the domain concepts in that way.
Right. I think we're nearly at the end. So Michelle says, your leader should be highlighting the work that the data engineers are doing, regardless of whether it's obvious to the user. Yeah, I agree. And if you have a good leader, that happens. That's not always a given. Okay, Bart says, thanks for the story, Jelle and Christophe. Always good to reflect on it again. It's Bart S. I think he wants to remain anonymous.
Sorry.
Thanks, Bart. I don't know. All right. Well, we're at the end of our webinar. I see some people dropped off, but there's still plenty of you here. I propose, Christophe, that you do the the paved road that you want to show, like how do we do this in practice? Like slides are nice, but Christophe is going to walk you through how we do this in practice. For those of you who want to leave, this will be recorded. You can watch it later. Thanks for your time. For those who want to stay, feel free to keep asking questions. We'll be around for a bit longer.
Yeah, so Jelle will...
it's Jelle, it's not you. Sorry. Yeah.
No, we're working it together, so...
If the clicker doesn't work, Jelle, tell me.
Yeah, I will. So one of the core principles we talked about for a platform team is building that paved road and providing that integrated experience so that people have an easy way to walk through all the steps that is needed to deliver that end result. So what we want to do right now is show those high-level steps and what that could look like in practice with a clear focus on ease of use and user experience. So typically it starts with an idea.
Yeah, we just use the arrows. I think the battery is dead or something. Yeah.
Yeah. So typically you start with an idea. And
we're not presenting. Sorry, I'm not sharing my screen. I'm an idiot. Thank you, Christophe.
Oh no, thanks, Stan.
Oof. Yeah. Sorry, Stan. It's coming there.
Okay, let's go.
IT. Yeah. Let's try it.
Yeah, let's go one back because it was not shared. So this is on high level all the steps that a typical data product has to go through. So it typically starts with an idea, and if you have already data cataloged somewhere and you know what data is available, people could browse in that catalog and see, okay, if I take this and this and I combine this, I can maybe deliver some value for my company. So let's try it out. Let's start an experiment to see if this actually brings value. What you can do is once you know that and you know what data you want to use and you have this idea, you can try to register a use case, register a project in a ticketing tool or in that data product portal that Christophe talked about earlier, and say, okay, this is the project I had in mind. This is the purpose. So you enter a description. And then if your data has data owners, they will have to approve whether that it's okay to use that data for that certain use case. Once that is approved, automation kicks in and the project is bootstrapped and everything is set up automatically. I will show you what that looks like in the next steps, but you would be surprised how much things you can automate during bootstrap time. Once you know the data access that needs to be in place, I think 70% of the work we do as a data platform team is making sure that everything is set up from this point on. And after this step, they can go end-to-end to production. So there's no more ping-ponging, ticketing, communication with the platform team needed once their project is in place. So let's say that the project is created, it's through the bootstrap phase. Then ideally you offered a kind of portal that gives that integrated user experience where they can start experimenting. For example, let's say that there's a project called Leads, random example, and then you have some buttons available that says, hey, click here to connect to experimentation. So click here to open a notebook. Or you have a button that says, click here to connect to the LBS console. That gives you access to your data, and then you can use things like Glue or Athena to experiment with data. Or there's tools like cloud IDEs, like Gitpod or Conveyor also has cloud IDEs where you can start writing code directly. So let's say you click that button that says click here, connect to experimentation. What you will see is that that the notebook will open immediately. You can import Python functions. Notebooks also have like an instance lifecycle script, which means that things can be set up at the beginning. Maybe PySpark can be installed for certain dependencies, so the end user doesn't have to do that themselves.
Yeah, maybe to add on this one, it's also important to understand that you can set it up that all the data access scope is immediately set up correctly in the right way. So it's just a one-click experience for the end user.
Yeah. Yes. For example, if you look at SageMaker, you have to enter a role that is assumed when the notebook starts up. You can build an abstraction on top of that, so that is automated. So the role, the AWS role of the project is automatically filled in, which means they immediately have access to the data because they knew what data they needed access to in the beginning when they requested it. Okay, let's say that you're done experimenting and you know what to build. So you've built a machine learning model maybe, or you know what analytics use case to build. So the next step is to actually do it properly, because probably you took some shortcuts to prove that the value is there. So now you need to code in an IDE and apply clean coding principles. And also for that, you can, for example, use cloud IDEs. The cloud IDE is an on-demand, pre-configured IDE that runs in the cloud. And once you open it, all the dependencies will be pre-installed. So that means all the, let's say, Java or Python libraries are there, but also all the plugins that you use. Also, the AWS role, again, will be configured so you can run things. In Cloud IDE, you can also run a notebook directly. So let's say that you want to tie those things more together. That's all possible in Cloud IDE.
Yeah. It's a contentious question here. But are there cases, in your opinion, where instead of moving from notebook to IDE, where it is okay to just schedule your notebook? I'm asking because we typically don't do that, but we do see it a lot of clients, right? So that's why I'm asking.
We do. I would always advise against it. And indeed, you have CLI tools to run your notebook. For example, recently we're using GitLab at the client, and they released a demo of an alpha product. And also in that demo, they even scheduled a notebook and they ran that in CI/CD. So sometimes it's a common practice, but I would say I don't believe in it, that it's a good coding practice.
Okay.
All right, so let's say that you've developed your product. So next up, what you do is you commit your code, you push to a branch or you push to the master branch, and then CI/CD kicks in. This is also something that a platform team can set up, or they can at least provide templates. So it's there out of the box, maybe with a cookie counter template or something like that in their Git repo. And the code automatically gets built, pushed, and then you have maybe some manual triggers or automated flows with continuous deployment that deployed automatically into the development or production environment team. When you're doing batch pipelines, you also need to schedule your data. So you need to decide how frequently do I run this process, and do I want to do a daily inference of my machine learning, or does it need to be real time? So also this can be done by the platform team, so that the Airflow is set up, it's secure, people have access to it, they can monitor things through Airflow. When a task fails, they probably want alerts to get alerted and proactively fix things before the business notices. And then finally, you want to scale this out, and you want to make it manageable. So every engineer, they need access to the logs, and you need to follow up on those alerts. You want access to metrics, and maybe you can optimize there and save some costs, like what is my CPU usage I requested in my machine. Maybe you requested 10 times as much, so you can scale it down again to save some costs. Maybe you want to run things on Spot instance, or maybe your Spark memory is not peaking, so you can decrease your amount of executors, things like that. So this is on a high level all the steps that you can walk through and deliver value end to end, and how a platform can enable that. As you can see, there was a very high degree of autonomy, and the use case team was able to go end to end. But all that undifferentiated heavy lifting was done or was set up by a platform team to make that as easy as possible without having to communicate again with that platform team. You could build all of this yourself, or you can give yourself a head start and have those steps automated for you, or have those available for you immediately, so that even the platform team can focus on more valuable things than setting up a compute environment or setting up your own scheduler. And that is where Conveyor comes in, which is our own SaaS product. We have Data-Mined. It's running at some very big enterprises at very large scale.
Yeah. All right.
All right. That was it.
Thank you. We've gone a bit over time, but those of you who are still here, that made a conscious decision to be here. So I like that. Let's see if there's some more questions. No. Let's see if there's some questions in the Mentimeter. If not, then I'd like to wrap up the session. So thank you, Christophe and Jelle, for your very, very elaborate and good presentation. I think you touched on quite a few important topics that are not always explicit when people give a first demo or first, indeed, the first architecture diagram. This is your data platform. Well, there's a lot more that comes to it. I really like the nuances that you put in here. So thanks both of you for the presentation. And thanks to the listeners and viewers for watching. you know where to find us if you have questions, right? Or you want to apply this in practice, and we're always here to listen.
Thanks all for your time.
Thank you.
Bye-bye.
Bye.
Bye.